In this video, we will identify the correct statement about transposons. We will compare DNA transposons and retrotransposons step by step and use simple visuals to make the differences stick. First, a quick reminder. Transposons are pieces of DNA that can move to new positions inside the genome. There are two main types, DNA transposons and retrotransposons. Let's visualize DNA transposons first. These usually move by a cut and paste mechanism. The element is cut out from one spot and pasted into another. This often does not increase the total copy number. Now, retrotransposons move by a copy and paste mechanism. They are transcribed into RNA, then reverse transcribed back into DNA, and inserted in a new location. The original stays, and the copy adds a new one. This is why retrotransposons can spread more rapidly. Now, let's evaluate each statement carefully. We'll mark each one as correct or incorrect and explain why. Statement 1 says, both types of transposons use an integrase enzyme coded on the transposon itself. This is incorrect. DNA transposons typically use a transposase enzyme, not integrase. Retrotransposons may use integrase-like enzymes, but the enzymes are not the same for both types. Statement 2 says, retrotransposons are likely to propagate more frequently than DNA transposons. This is correct. Retrotransposons use a copy and paste mechanism, which increases copy number. DNA transposons usually do not increase copy number as efficiently. Statement 3 says, retrotransposons are more common in prokaryotes, while DNA transposons are more common in eukaryotes. This is incorrect. Retrotransposons are extremely common in eukaryotes. For example, about 42% of the human genome is retrotransposons, while DNA transposons are only about 2 to 3%. Statement 4 says, DNA transposons produce full-length transcripts that help them move. This is incorrect. That description fits retrotransposons because they are transcribed into RNA and then copied back into DNA. DNA transposons usually move directly as DNA. So the correct statement is retrotransposons are likely to propagate more frequently than DNA transposons. The key idea is copy and paste versus cut and paste. Copy and paste increases the number of copies much faster. Quick recap. DNA transposons typically use transposase and move by cut and paste. Retrotransposons use an RNA intermediate and move by copy and paste. Because the original stays and a new copy inserts elsewhere, retrotransposons can spread quickly. Keep this mechanism in mind when comparing statements.